Hi everybody, how's it going? Welcome back. So I'm really excited today because we're pretty much done with the simple linear regression stuff. I'll give a quick aside and say there's a lot of other stuff you could look at. If you were reading this from a book, you would see a much more statistical point of view, and stuff like R squared value would come up, which is kind of like the loss function a little bit. It's a measure of accuracy, and there's a lot there that I'm not going to discuss. So today I'm going to introduce the idea of multiple linear regression and the idea of binary variables at the same time. And they work really well together if you show them at this step at the same time, even though they're kind of separate ideas. So that was probably a little bit confusing. Let me show you what I mean. So say, for example, that right now we're looking at these people and we're assuming, not really thinking about their gender at all or whatever, any other variables. We're just looking at their age, and so it doesn't matter who they are. But we probably have other information about them, and we could use this to predict the height, possibly. Maybe it's useful, maybe it's not. We'll find out when we look at it. But say that we do have other information. And I'm going to use the traditional way, so I'm going to give the apology of sticking to traditionally you're either male or female. This isn't really true, but I'm going to assume that for moving forward. And so say that the red points were actually males. And maybe we had another group of individuals, the females, as red points up here. And I'm going to stick with the same color, but that's just to say it because it's really the same group of data. It's the same training set of data, but we happen to know that these people have a binary indicator variable, which I'll define now. We'll say that, and if I denote this as x1, then I'm going to say x2. So x1 was their age. x1 equals age, and then x2 is equal to kind of the split thing. If you haven't seen this in math, it means that it's going to be one of these two things depending on the conditional, and this will make sense. So really, x2 is equal to 1. Okay, so it's either 1 or 0. It's not both. It's 1 or 0. And it's 1 if they're female. Okay, so 1 if female and 0 if male. Okay, and so all of these people, all of these had a x2 equal to 0, and all of these two had an x2 equal to 1. Okay, and so you notice I just kind of picked arbitrarily which one was female or which one was male. It has a slight impact on the interpretation of things, but it's not going to change the true math in predicting at all, really. Okay, so if the top ones are females, the bottom ones are males, then notice what I did, and I tried to at least make, maybe I didn't, but I tried to make the slope of these lines the same. Okay, so if I was to draw these two, kind of give them each individual lines, then the slopes were the same, and that's not necessarily true, and I'm actually going to avoid the case where it's not true, although it could be. So if we were to draw these two lines, they would be parallel, as in they would never touch. So they have the exact same slope, but there's some distance between them. There's a distance between them here, which should be the same because they're parallel. So this distance is always exactly the same, even though it might not look like it from the picture. This value is equal to something we haven't shown yet. If we were to make this model, if we were to add this into our model, we would need some other slope value, or it's kind of a slope, but not really anymore. It's beta 2, we add beta 2 x2, and so if x2 is either 0 or 1, well, you can think about it. If x2 is 0, then it would be this line. Okay, it would just be beta naught plus beta 1 x1. But if x2 is equal to 1, then the line is beta naught plus beta 1 x1 plus beta 2, not really times x2, because it's just, that's times 1. So you can actually think about it. The other line for the females, and let me just show it explicitly, the male line, so male y hat, would be equal to beta naught plus beta 1 x1, whatever the age is. We're not really thinking about what the age is, just whatever that value is. And then if x2 is 0, then that would mean this thing is cut off. So it's plus 0 here. So it's just that normal line. But female y hat is equal to beta naught. And if you, again, the value over here, this would be 1. So it's just beta 2. And so this would be beta naught plus beta 2. You can kind of put this in brackets. You don't have to, but I'm showing that it's in basically adding to the intercept, and that value beta 1 x1 is not going to change. So really all I did, this value here is beta 2. Okay, so this value is beta 2 because it's just the increase between the two lines. It's saying if you're female, I'll bump you up by this value. That's the interpretation of beta 2. And it's going to change your intercept term, so you could choose to look at it like this, and then instead say that the line's intercept, which just means if we set the other variables, which is just x1 in this case, equal to 0, well then this, okay, so this value, this must be beta naught, this value right here, and then this value must be beta naught plus beta 2, because that's beta naught, and then you add that same distance here, that's going to be beta 2. Okay, so what I just motivated was both the idea of using a binary variable. We can use these, and so I'm going to just call this, just so it's written down here, a binary either variable or indicator, binary variable. Okay, so 0 or 1, it's either one of these two things. And also, we actually just switched this to what we call multiple linear regression, because we used multiple things to predict. Okay, it has nothing to do of whether we used binary variables versus continuous variables like age. It really just means that we're using multiple things to predict. And so I motivated these two at the same time because I can draw them on a 2D graph like this. Imagine that I tried to show you this with adding a continuous variable. I could have done that. I could have shown, I could have made another axis here, maybe made this 3D, and then I'd have to draw this kind of, points are two-dimensional, but then they also have a height, so they're 3D, and that's just confusing. But we will end up using this a lot in practice, as in your model predictor, you're going to be using these types of variables, many continuous variables. If we instead made x2 continuous, or we added one here, there's no reason we can't just keep adding things. We could add in some other parameter, so beta 3, and then x3. We add in some parameter times some input, and that's going to be our new line. Even though it's kind of hard to visualize at this point, you can still add these in. It might make our model better. It might even make it worse. It's going to be better at predicting on the training set for sure, but it might not be better at predicting at the test set. And yeah, so that's the idea of multiple linear regression and binary variables, and I will see you in the next video.